Okay, a bonus YouTube on a Sunday night here. So, looking at the SurveyMonkey, and thanks for those of you who filled that in, I got some feedback that was reasonably consistent on a couple things and inconsistent on a couple others. Um, I'll talk about them in class briefly, but the consistent one was on the case studies, and I think a general feeling that it's a task that's a little bit underspecified, and you're not quite sure where it's going, and would like a little more guidance. And there's two reasons for that. One, well, three. One is that we really have a limited amount of time in class, and I've been rather deliberately prioritizing the information and the content and the tools because the decision process stuff that's a big can of worms, and I don't think it's front and center for conservation ecology, and so I don't want to go too deeply into it. But that does leave you guys in a bit of um, a quandary into what to do with the case studies. So I was going to try and go through this again and perhaps leave with some additional guidance on it. But as I said on the first day, this whole case study thing is a little bit of an experiment, and we're seeing how it goes as it goes along. So at the end, you guys will be doing a presentation, and the idea there is to present a science plan for your conservation projects, and that you want to be able to defend the choices to provide, to prioritize some set of science questions over others. Why are you asking these things and not those things? And rather than saying, well, we think that this is where the biggest innovation in science is, or this is the coolest science we could be doing, or this is the most interesting science to us, we want to be defending those based on the needs for the decision makers. And so, why are we doing this? Well, partly it's to put yourself in the manager's shoes and understand better why agencies don't put out proposals that just look for any flavor of good science for their reserves and projects, that it's not an efficient use of their very limited funds. And also think about why good science that genuinely identifies a problem can and sometimes should actually fail to result in action. And it's because it's difficult to do science on all the various aspects of trade-off, some of which are social, in a single study. And so it becomes a very difficult problem. And I think it's not a difficult problem just for scientists. It's a difficult problem for managers as well, of trying to put all these things together. So if you remember, we were moving down towards getting a situation analysis, or identifying a set of targets like the sturgeon, White River tributaries, riparian forest corridors over here, identifying threats and factors, and that this is the first task: identify what is most important, and to be able to state why these are the top priorities, why these things rose to the top and other things did not, because surely in a landscape like this there's more than four things that you could be interested in, and that this is what this group has said that they were interested in. The second task is then to prioritize still further and consider amongst these things what are the most important threats, targets, threats, and factors and strategies. And it doesn't mean that you won't work on things that aren't in the top priority, but you basically have to be able to rank things and say, and generally this is done by saying, well, if we were to work on one thing like rapid urbanization, we might feel like we have the best opportunity to change most of our factors toward the direction that we'd like them to go. But so this is the stage where we're getting to this next week, where we've already identified the targets, the threats, these contributing factors. You want to think about what those actions are, and we want to think about prioritizing within the situation analysis where we think things need to go. Now, within the context of the open standards, there's the next thing that happens then is to do one of these things that's called a results chain, and this is based on some theory of change. That if we do X, then Y will happen. That's all a theory of change is. And so this conceptual model is trying to say the current state of the world, and that our results chains are trying to look at anticipated results. What will happen if we do something? And you can see down here on this diagram on the page the project impact conservation target, they set goals. We're calling those objectives, but these are linked to these targets. And we want those then to be SMART. In other words, boy, S again. I forget these things every time I do them. Measurable, actionable, realistic, and time sensitive, and specific is S, specific. So here in Open Standards, box 2 in the Open Standards, setting good objectives, results oriented, measurable, time limited, specific, practical. These are the same kinds of things that are in these SMART objectives. So basically the idea is it's difficult to hit the target when you don't know what you're aiming for. And so if we're saying that we're looking for forest corridors or sturgeon, we have to say, what is going to be the measure of success? How will we be able to measure the state of sturgeon to determine whether we are moving toward our goal or not moving toward our goal? Sorry, I hit a thing here. And therefore, we want these things to be as clean and as crisp as we can possibly make it. Now, we recognize that that might be hard given our situation, our understanding. These are different cases, but that's what we're aiming at. And so here's one of those results chains. Again, this is again from Open Standards. And you see that they talk about the forest corridors as a target, and you might have some minimum width of forest corridor in kilometers or evidence of corridor fragmentation. That you have these little purple triangles are indicators of success, and the goals are in there. So you can also have objectives for these intermediate stages. And so in this case, you're reading from left to right. You're trying to improve land use planning, and if you do so, then you would expect conservation-friendly zoning regulations developed, and the objective there might be approval of zoning regulations that include a moratorium on new building permits in state-listed unique areas, and so on and so forth. Now, notice that an awful lot of these examples seem to have, relatively little to do with biology. There are often a lot of policy changes that would result in the outcome, and that's fine. And that when we do our situation analysis, we may, in fact, also find things that are policy oriented priorities, and that's okay. But when we get down to writing a science plan and asking science questions, those wouldn't be part of the priorities, because we can identify that there's policies that may need to be done, but there may not be a lot of reducible uncertainty that can be addressed with science. And so we're going to be writing the science plan for things that can be addressed with science. So just a few caveats. This way of thinking may be new to you. I recognize that. And we aren't trying to make you experts in this flavor of decision-making or decision-making generally. I teach another course in that. But this flavor of decision-making is just one among many. It's just, I think, relatively simple and straightforward and can be digested in the short period of time. Particularly the federal government has its own process with a lot of the land planning rules and all the NEPA stuff, but we're not going to pretend to go through a long NEPA process. That would be just onerous. So this is a good way to cut to the quick and justify why you choose what you choose for your projects. And as I've said in class, you don't need to be right, you just need to be plausible, right? So we encourage you to talk to the experts that you have for your cases. But if they're hard to get a hold of or they don't have definitive answers, you just need to take your best shot at setting priorities. And if at the end of the day, you say, let's use the Northwest Forest Plan, that you set your main targets as being mid-elevation forests and black-tailed deer and panthers, and you just completely miss the marbled murrelets and spotted owl, well, that's a pity, but it's not going to, it shouldn't necessarily thwart what you're doing. You're still saying, given the targets that you've chosen, and given the threats that you understand and the factors that you understand that contribute to those threats and the actions that you recognize as being able to influence those targets, what makes the most sense in terms of trying to develop some science that will help reduce uncertainty and move the whole thing forward. Okay, so and then getting down to the end of it, your final project as individuals is some sort of research RFP, a request for proposal. And by setting up these conservation objectives for priority targets, you can focus on what questions you most want answered. And these answers, can focus on the actions that you might take, the factors, the threats, the targets, the theories of change. Maybe the big deal here is that you can say that you have a theory of change, but you really have no idea whether it's right. And what you really want to do is science that helps verify whether this chain of actions might actually come to be. Monitoring outcomes of actions or setting priorities. So for those projects that are early on in the planning stage, maybe the science is really about setting priorities. And what you really need to know is you say, what are the species within this ecosystem or that ecosystem that are going to be the best indicators of the quality of that ecosystem? And that's a research question. The important thing is to capture what you feel that a decision maker needs to know in order to make the best decisions possible. And so you need to accomplish two critical tasks in your RFPs. Make a clear statement of what research you're calling for, and including how it will inform the conservation decision process. And that's why we're spending some time thinking about the targets and that situation analysis, because if you can enunciate a clear situation analysis, then you have a clear idea of what kinds of actions you could be taking and how they may be constrained by a lack of information. And what you'd also like to do in that RFP is make a clear statement about your decision criteria for picking some proposed science over others. So part of the our RFP process is to tell the audience what will be the attributes of a good proposed piece of research that you might fund. And I will get to this a little later, but this is what we call a consequences table, where what you're doing is looking at the consequences of funding different kinds of projects. And so imagining this down the road, you have project 1, project 2, these proposals that come in to do research on the project. Well, you can identify objectives, and it may be to whether the project addresses a critical priority question, whether it's framed to inform the policy priority actions, whether it addresses stakeholder concerns, whether it's innovative science, robust methods, achievable for the budget. These are all things that you might use to pick one project over the other, because realistically, if we were actually doing this and you actually put out this RFP, you know that you'd have more science that you'd like to fund than you have money to fund. And so you're going to have to say no to some darn good projects, and you want to be able to identify why it is that you would say no. And it may be because they don't, it's good science, but it doesn't really address some primary stakeholder concerns, or it's addresses a pretty critical priority question, but you don't think that they'd actually be able to get it published because it's not innovative, and that's an important part of the outcome, anything like this. So those are things that came to my mind, but you can decide for yourselves what these objectives are that you'd like to achieve by the science that you call for in that proposal. Okay, so here is this proposed timeline that I suggest that we do for the rest of the quarter. Is week 5, that's the week coming up, is that we want to get those targets with objectives, threats and factors, and potential actions. So this is basically adding some specific objectives for the targets and actions onto what you already have. That next week we'd be looking at a prioritized situation analysis. So basically you take that same set of factors that you have, but now make some things more important than others. And that week 7 would be preliminary research objectives. So where on those results chains or in that situation analysis do you really feel like that there's major pieces of, major unknowns? And so during weeks 5 and 6, you guys should start to get a preliminary list of these things, so that by week 7 you can kind of put it together and have a justification for those. Week 8 is developing some decision structure for the research question priorities, and week 9 and 10 be presentations. And so that's my vision for this, and I recognize that it's a big ask, and it's an experiment. We don't know how it's going to come out exactly, but we're hoping it will come out reasonably well. And I suggest that if your groups are struggling with it a bit, make an appointment with me on Wednesday or some other day of the week, and I'm happy to chat with you about it and sort of brainstorm how it might go for you. I hope this helps a bit, and see you on Tuesday.